Hello friends, welcome to Civil Engineering exam. Today we are going to see the problem related with foundation engineering in the topic of site investigation, particularly seismic reflection method. So the seismic reflection method is mostly used as an indirect method for soil investigation. So in that seismic reflection method, so one source is there, so we can provide the shock waves, and the shock waves is two type of waves will be created. So one is direct waves, another one is reflected waves. So the direct waves come along the surface and reach the receiver. Okay, so in the shock waves it will be reach the A point of the hard layer. So here is a soft layer and here is the hard layer. Okay, so the reflected waves reach the hard layer and reflect and receive the receiver in the particular time. Okay, so now we can take the direct waves. So the direct waves time to take the direct waves TD equal to, so it will go by the simple surface. Okay, so now distance divided by velocity. Okay, so distance divided by T Vp1. Now this arrive from the formula, that is velocity equal to distance by time. Okay, so from that relation we can derive TD equal to L divided by Vp. But here the TR, so we have to find out the TR, that is reflected waves. So now here also length is required. So length is here OA and AB. So length is AB plus OA. Okay, so divided by, so the velocity is Vp1. Okay, so now we can take TR equal to AB and OA is the same length. So now we can take 2AB divided by Vp1. Okay, so now AB is we can use the Pythagoras theorem. 2 into AB value is root of L square plus, sorry, L by 2 square plus H square divided by Vp1. Okay, so now solving this, we can multiply it by 2. So here we can take L square plus 4H square, here is root, divided by Vp1. Okay, so here is the TR value. Okay, so again we know the formula Vp divided by Vs equal to 2 into 1 minus Poisson ratio divided by 1 minus 2 Poisson ratio whole power 1 by 2. So using these formulas we can solve the problem. So now the problem is a loose deposit over the consolidated clay is underlying by the bedrocks. So the previous surface investigation in the area suggests that the bedrock is almost horizontal during the reflection survey. So it's almost horizontal. So the reflection survey we can take these formulas. So now the receiver marks the arrival time of waves. So that is direct waves time is 41 milliseconds and reflected waves is 267 milliseconds as a result of impact loading of 37 meter. Okay, so the impact length is 37 meter. So the receiver from the receiver, so then determine the P waves velocity. So now we can find out the Vp value and thickness of the layer. So thickness we can find out the H value. Then further using the Poisson ratio 0.3 we can determine the S waves, that is secondary wave velocity also. Okay, so now we can find out the Vp value, then H value and Vs value using those formulas. Okay, so now we can take, first thing is we can take Vp equal to the direct waves L by T dV. Okay, so now using this relation we can find out the Vp value. So now we can take L is given, that is 37 meter, divided by TD is given, so that is direct TD is here and TR is here. So okay, so TD is 41 milliseconds. So 41 into 10 power minus 3 meter second. Okay, so now we can take the millisecond into meter second. So now solving this we got the value of 902.44 meter per second. Okay, so this is the Vp1 value. Okay, so next thing is we can find out the H value. So using the formula T, here is a T R value is there. So T reflection equal to, so the formula will be root L square plus 4H square divided by Vp. Okay, so now we can substitute all the values over here. So L is, so here TR is given, that is 267 into 10 power minus 3 equal to root of L square, that is 37 square plus 4H square divided by Vp values we found out 902.44. Okay, so solving here the only unknown is H. So solving this, we got the value of H equal to 119.04 meter. So we found out the second question answer also, H we can find out. So now next thing is we have to find out the Vs value. So we already know that the formula for Vs divided by Vp. So now Vp divided by Vs equal to 2 into 1 minus Poisson ratio divided by 1 minus 2 Poisson ratio whole power 1 by 2. So now we can substitute all the values over here. So now Vp is we know. So now we can take the 2 into 1 minus Poisson ratio is 0.3 is given divided by 1 minus 2 into 0.3 whole power 1 by 2 equal to, so Vp is we found out 902.44 divided by Vs. So here the only unknown is Vs. So now Vs equal to, we found out 482.5 meter per second. Okay, so this is the final answer. So this is a method we can solve the problem. Again we will see next video. Thank you.